go. Okay, so hi everyone, thanks for coming. So I'm Simone, I'm now a postdoc in Utrecht University. I spent my PhD at the Complexity Science Hub, and this is the last paper of my PhD. That's also where I met Maria. And so today we're going to talk about AI and who's using AI to code. But I had like a small, being that we have a lot of time, I had like a small introduction about some of the perspectives that I have on this subject. And the first one is that you have a lot of narratives for which you can talk about the subject I'm talking about here, and each of them can be interesting if you drag the thoughts that I'm bringing here. So this is a plot that shows the number of books and manuscripts in Europe through the years. So you see this very exponential growth on the amount of knowledge that humanity has created, both for books and for patents as well. So through a lot of years. At the same time, we didn't become smarter, at least like genetically through this period. So how does humanity create this expanding exponential body of knowledge, and how can we keep it expanding? There are different narratives for this. The first one is the division of labor, which can be seen as the result of the expansion of the collective knowledge. So if you think about the tasks that we were doing in the past as little bricks, and if you think about the tasks that we perform now, maybe now it's 2026, not 24, but so through the division of labor, we divided the different tasks that each person performs in society, and the consequences of this expansion body of knowledge, one is specialization at the level of the individuals. Another one is the interdependence of these individuals and the rise of teams. And maybe a third one is about coordination. And these three topics are very interesting to me. I'm really interested in each of them and how the interrelations between them portray different parts of the society we live on. But maybe a question that could arise is, okay, this is like the prospect until 2023. What if now we sort of hug with an AI and we use this perspective through artificial intelligence? So we can revisit each of these aspects with AI. So let's go back. So let's start backwards in coordination. So how does AI shapes the coordination inside teams, inside institutions and firms, between different players of the team? Does the team interact with generative AI? Does each of the individuals interact with artificial intelligence, and how this shapes new dynamics of coordination inside the team? And again, the dynamic of specialization and coordination at the individual level. So today I'm going to talk mostly about this one because you sort of have to start somewhere to sort of build from it. So apart from artificial intelligence as the matter of subject that I study sometimes, I also use it for different other projects. So being that I had a lot of time, I wanted to introduce a couple of other ongoing projects, so maybe we can also chat about them afterwards. The first one is about digitizing the historical patents with Christopher. So in practice here, the issue is that we can geolocalize and we can extract a bigger body of knowledge from patents that have not been digitized yet, or through which it was impossible before to digitize. For example, the first issue here is that we want to extract the inventors, the specific location, or maybe some figures of the patents. But it was very, very difficult before, also because of the heterogeneity of where this information is inside the patent. Now the extraction of this information has become way easier. So from a big historical patent records of a historical time period that comprises also the Second World War and so on, we extract information about their locations through an AI to have a structured data set about inventors in periods of history that were not studied before, achieving pretty good performances. And this is one paper that is out soon. Another one is using, so instead of the video here, there was like a nice AI little object, because here what we wanted is to simulate how a human does research into the firm's website, grasps information that is interested into, to have a neater landscape about what firms do and innovate in a certain field. For example, for the Dutch agro-food sector. They were interested in understanding which are the opportunities of collaboration and innovation in the sector. But unfortunately, firms and trademarks are really not representative of what they do, given that only 5% of the firms in the Netherlands actually patent or publish trademarks. So we use an AI that understands the whole tree of a main website of a firm. So we start from the main website, and by understanding the tree and the depth of each of the firm's websites, we are able to extract in a sort of like efficient way where the interesting information about firm's production is. Yeah, hopefully working out soon. And this is sort of like a topic landscape. Doesn't tell you much, but we were mostly interested in this part about food, beverages, and ingredients, for which actually we can understand which firm does what and the nuances between them. All right, so now we come to the topic of the talk, which is large language models and how people uses it for coding. So how do we measure LLMs? How has been measured in the literature? The first is asking people. So you ask people how they use LLMs, how much they use it, for which tasks they use it. The second one is count how often they search some Google terms in Google. You collaborate with OpenAI, Microsoft, or someone else that have very in-depth information about them. Or, as you recently saw with Anthropic, Gemini, and so on, you get information about on the charts. But so why people is interested in that, and why do we need to know this adoption and impact? We want to understand how intensively this impact is. What are the productivity gains? Which jobs will be automated? I know that some here also do work on that. But also, what are the heterogeneities in the use? So not everyone in the same job is the same. So adoption between groups, gender, experience, geography, and the impact that it has in those subgroups. Also because like slow diffusion of other technologies actually explains the international income divergence between countries. And there are many more reasons. One is the left behind regions. So the regions that through not adopting or through this very rapid transformation will change the occupational landscape in a very short amount of time. This is, for example, the trajectory of other technologies like the computer and internet. And this is the point of AI now. So it's such a way more rapid diffusion of the technology. And this is why we have to understand how it is diffusing and how to sort of cope for this diffusion for good. And this, if you want to see from another perspective, that's a diffusion by million of users by the years after the release between ChatGPT and the internet itself. All right, so then what did the literature study about who uses AIs? There are three perspectives I will present here too. The third one is through chats. So who has access to the chat like OpenAI or Anthropic? The first one is representative surveys, and they have some sort of shortcomings because usually it's only within some countries. You don't have a rate of adoption over time. We have some sort of, usually social desirability bias skews the results. That's the evidence from the literature. So like the willingness of revealing some informations or the type of information you want to reveal depends on the social group you are in, and that skews the results with like an error that is way bigger than the estimate itself, sometimes. The other ones are RCT derived, but there are some shortcomings. Usually they are specific to some firms or to some geographies. Usually treatment is access to the technology itself, but not much has been said about the intensity of the use. And usually it's a rather narrow time range, and for some simple tasks, like for example, call centers and so on. So the contribution of this work, so the first one is we present a method to detect statistical AI in code contributions. We estimate this share of AI code contributions for 6 countries in the range of the adoption of AI. And we relate this intensity of use to individuals, such as their characteristics and the activity or productivity or the experience that they have. One key finding maybe to bring home is that it seems an evidence that for these tasks of software, experienced developers bring more out of AI adoption. So this is the study design. So in practice, these are all the GitHub users. GitHub is this open source platform of code, and we can geolocate a lot of people around the world. Out of them, we can extract a very, very fine-grained information. So I think that one of the things that is fascinating about GitHub is that for this very narrow sector, that is software production, we can actually access activity day by day, and we can actually take a look at what actually people do day by day, which is usually hidden from other sources of data. So actually, we can pick. This is AI generated, but of course, but these are what commits are in GitHub. Commits are like snapshots. Probably I don't have to tell to the computer science department, but it's snapshots of changes of code, and we can check each day, line by line, what each programmer changes and what it does. Plus some metadata about the author, the geolocation, the time, the topic. This is how a diff file looks like. So we look at the lines removed and the lines added for each of the function and each of the users that we geolocate through time. And we focus on functions. So we focus on functions that get modified substantially. And we focus on them because it's a rather elemental unit of code that it can be connected to a task that also has multiple informations about what the task performed, its inputs and its outputs. So we sampled 2,000 Python programmers for the 6 countries, and for America we pick all of them. So we wanted to have a rather exhaustive data frame for the US to study its adoption and what are the consequences of adoption. We collect their code contributions, and we classify within each commit if functions as human or AI generated.
So
yeah.
So 2,000 Python programmers on GitHub per country year, and then 160,000 users. So
yeah.
What's the difference there?
So like it's more or less 60,000 for the other 5 countries,
okay,
plus 100,000 just for America. Because like each country, so we picked 2,000 random for each country year.
Okay.
So it's like 2,000 for each country year. It's like 5-6 years. So it's like 10,000, 12,000 per country. And that what remains is because for the US we pick all of them.
Okay. Yeah, I get that. Yeah.
Also, yeah, you can interrupt me. We have plenty of time, so just interrupt me whenever. Okay, so then a very simplistic way, again, AI generated the philosophy of the first part of the work. How do you detect if something is AI or not? Usually in standard machine learning classifiers, you have images, for example, of what's a cat, what's a dog, and you have a lot of examples that describe what's a dog, what's a cat, and through this training set, the machine learning classifier tells you which one is a cat and which one is a dog. So similarly here, we do a detection procedure, and I think that this is an interesting part of the paper. We use this pipeline to generate artificially made code. And how do we do that? So we can embed code in a vector representation of what the code does, and we use this vector representation through an AI classifier to spit out a probability between 0 to 100, between 0 and 1, that is AI generated. Once the detector has been trained, we evaluate it with out-of-sample tests. But then how do we tell the classifier what's a cat and what's a dog, what's human and what's not? So we use this 2-step pipeline. So we take code that we know for sure it has been made by humans, either from 2018 or from other data sets that are labeled as human. We make the LM describe in terms of the task and the input of the output that the function performs. So from Python code becomes natural language, and from natural language we recreate examples of the same code but AI generated. And then we feed this to the classifier to classify what's a cat and what's a dog. And I think that this is an interesting part. I think it relates to this Platonic representation hypothesis from Anthropic. So you can imagine that the truth and a world truth can be represented in this space Z, and this space Z can have two different types of representation. One is a 2D projection of this reality, and another one that is a text description. And what they try to test in this paper is that are the two representations, so are the two vector representation of these two realities converging as the model grows. And I think that this is, so they see this, so this is language performance, and this is vision alignment. So the better the model, the better it can translate between language and an image. This is very similar to what we do, and I think this is an interesting perspective because you can use AI to be a sort of like translator between these different representations. So then we evaluate this with an out of sample. So we pick other out of sample code made by humans, and this should peak around 0 because that should be human, and this should be peak around 1 because this has been generated by LLM. Being that reviewer 2 was not satisfied, we had to pull in a new data set. So what we did, we pulled in wildchat. This is not out of sample, it's out of data set. So it's completely another. This is not code made by GitHub, but is a code made through chats. So researchers can opt in to use state-of-the-art models as a chat in exchange of them recording the data, basically. So you have normal chats like that, but then we can extract from all these chats the chats that are actually regarding Python code. And from the chats regarding Python code, we can extract the functions created by AI here to classify if that was actually AI generated or not. So this is actually, so we extracted all these functions, and then we distinguish between synthetic and assisted. Synthetic if it's the code generated by AI was on the first round with AI, so turn 1. Assisted if it's in the next turns. And this works remarkably well. It doesn't work as well as in the out of sample, so there is still some stuff to improve. Yeah. Okay, so here are the results. So the first one, we can study actually AI adoption dividing years by quarter. So each quarter we take the whole volume of code and we detect if that was generated by AI or not. This is America, so the whole range of the 100,000 and more programmers. We kind of do the same for all the other countries, even though the sample is a bit different. We do see that America leads adoption, but it seems that the other countries are like some months behind. They're not like exponentially behind America. We see that China is not adopting that much. It's also hard to interpret China's result, to be honest, for many reasons that we can for sure discuss. But we were more interested not only in the amount of adoption, but also what it does and what are the characteristics to the individuals. So we do not see gender disparities in the adoption. At the same time, we wonder how much selection there is in GitHub also because the representation of female users is around 10% with respect to male in GitHub. So there is a selection. But we do observe that, so being that we can track individuals through time, we can say how many years of experience do they have on GitHub, and we observe that youngers adopt AI more than very experienced ones. At the same time, we want to understand what are the impacts into productivity and exploration. So we create a panel data set, so we can track each user quarter, how many commits do they do, how many new libraries do they import, and so on and so forth. And we use two kind of dependent variables. The first one is the number of commits to sort of have a proxy for productivity, and another one that is more about exploration, which is how many new libraries do they use, how many libraries, and how many combinations of libraries they use. So how do they combine old knowledge to create a new product? And also how do they combine new combinations of old knowledge? So when do they introduce a sort of novelty in the combinations? So and these are the results. I will guide you through them, but this is one of the main features. So in practice, this is the effect on commits. Either if you pick all the possible commits, or if you pick commits that that modify multiple files, or if they import some libraries inside the commit. These are the library use. So these are the ones I just told you. These are the library use. So in practice, we can either pick if they import libraries, and we focused also on combinations on the top 5K libraries that is ever used in Python, or if we coarse grain to a more task level about what this function do. So for example, matplotlib and plotly are gathered together in a visualization tools and so on. Or if they import individual libraries. And the same goes for library entry. So being that we can track the history of these users through time for America, we are able to say, oh, this is the first time that actually this user uses this thing, or he uses this new combination. So we see an overall positive effect of AI on productivity, exploration, and learning, and so on. But an interesting result is when you split this productivity effect between people with more than 6 years of experience and less than 6 years of experience. So strikingly, the low experience ones that actually we saw were the ones that adopt more. Actually, we do not see like a neat effect on activity and exploration. So yeah, as an outlook, we have generated this microdata-based evidence for large scale about AI adoption over time. We observe these differences over time and geographies, and it seems that we estimated boosts of AI use, but especially concentrating among the experienced ones. As an outlook, as I told at the beginning of this talk, this was at the individual level. Sorry. Being that we can track these users through time, we can actually understand user trajectories and how they can learn, and what's the structure of these commits, and what does it explain about what do they do, and what do they learn. That's one of the next steps at the individual level. At the same time, being that we can track their coordination in teams and organizations, we can actually understand how this impact of AI affects this layer of coordination. That's where we are also moving towards. And yeah, I think I leave you with this picture in Budapest about our last gathering of the co-authors. That's the QR of the paper, and yeah, being that we're all scattered around the world, it's very hard to meet each other. So that's one of the last time we were together.